use a short blast or a prolonged blast, and that's what they're talking about. What we have is a short blast, it's about 1 second long, prolonged blast is 4 to 6 seconds. Big thing to remember in the maneuvering signals is that there's a difference in international and inland. International is, I am doing this, I'm actually doing it, it's a signal of action. Where inland is intent, this is what I wanted to do. So you're asking the other vessel, is it okay? And so that's what you're looking at, that's the difference. So one short blast, the one short blast, I'm altering course to starboard, so to pass you port to port. That's what you want to remember. Two short blasts, I'm altering course to port, so to pass you starboard to starboard. Those are the maneuvering signals. The three short blasts is I'm operating the stern propulsion. And all that means is that your gears are in reverse. It doesn't mean you're backing up. It means your gears are in reverse. You may be slowing down. You may, be trying to stop, or you may be starting to back up. But it's to let the other vessels know that that's what you're doing. Four short blasts is an identity signal for a pilot vessel in restricted visibility. Five short blasts, doubt. I'm in doubt. I don't understand what you're doing. I'm in doubt, or it's in danger. You're doing something here that's going to put your vessel in danger. Let them know. So we talked about boxing the compass. And boxing the compass, we talked about that. That used to be, and anytime you went on board a vessel, this is back in the times when Kenny first started, on boats. It was a seagoing skill for the mariners. When you'd go on board, they'd ask you, do you know how to box compass? And it was to show your knowledge your little bit of knowledge about navigation, about what you were doing. That's what it was. And our compass card today is 360 degrees is what we use for doing, for running the vessels and for, for steering and for our courses. At that time, it was only 32 points. So when we talk about boxing the compass, one of the things we want to remember is that 1 point is equal to 11.25 degrees. Easy to remember if you remember 360 degrees in a compass and there was 32 points, you can just whip out your calculator and figure out 11.25. But that's what the points are. Now the way they work, and we did this last week, and we'll just go through it real quick, is you got the cardinal points, which are north, south, east, and west. And then you've got the bicardinals, which are in between those. These are the cardinal points. North is the greatest, south is next, east and west. And so you've got bicardinals, and they're named for in between the points. You've got northeast, because north is greater than east, southeast, because south is greater than east. You've got southwest and northwest. Those are called bicardinals. And then you've got inner bicardinals. The inner bicardinals are the other points there, the other 8 that we're talking about. So that gives us 16, and then north, northeast, east, northeast. And if you go down and you're looking at that, and you're looking at the compass, you can go through, north is greater than east, so you can start naming the ones, by which one is greater. Knowing that north is greater than northeast, so it's north, northeast. East is greater than northeast, so it's east, northeast. And you go around and do it that way. One of the things that you're going to see on Coast Guard questions, a lot of times you'll see questions and you'll be reading through the question. Make sure that you read the stem of the question, the beginning of the question, you read every word of it. It's like Kenny was saying. You've got to make sure you read every word. One word can make the difference in what the answer is. Another thing that can happen when you're reading these questions is you'll read through and you'll say, well, that answer's right. And that answer's right. But the problem is that A might be right sometimes, and B might be right sometimes, and C is never right, so you throw C right out. And D is right all the time. So you want to pick the one that's right all the time. Same thing as might be right all the time, or it's the most correct answer of the ones given. That's another thing you may run into. One example that we use is an apple. We take an apple and we look at it, and we know an apple is red. Yep, okay, it's red. An apple's red, yeah. Or it could be green. An apple's green, yeah. There's green apples, so you know, you could be A or B. So A and B, if you looked at it and you're reading them, A or B could be right. It's a vegetable. Now, an apple's not a vegetable. It doesn't fall into the vegetable class, you know.
D, a computer.
D, computer, yeah.
iPhone.
Could be. That would be that would put it in the right answer. Or D is a fruit. Okay, so there you are. That's just what I'm referring to. Because D, it's always a fruit, regardless of what color it is. It always falls into the fruit category. So if you're looking at that answer, or these questions, the answer would be D, delta. So when you're reading those questions, make sure you read them all. Make sure you read every word in the question, every word in all 4 answers, and then make sure you know what you're answering. Now we're going to do a weather briefing tonight. Weather briefing, or the weather part of this course, is part of the Navigation General. That's where you'll see the weather. You'll have questions throughout, you know, the home study questions, but on the exam, it's in the Navigation General. Unfortunately, there is not an open book to go pick up that you can go look and say, okay, this is, you know, find the answers for weather. It's stuff you've got to remember, and you think, well, it's kind of simple to remember. So, and it is for the most part, because they make it fairly easy to remember parts of the weather. Just you have to remember what the relationships are between them. So there's 2 memory aids that we use. These 2 memory aids will help you remember all about the weather. The first one, memory aid number 1, there's 2 weathermen right there. U.S. Weather Bureau, they're on the Ouija board. Weathermen are stupid. You know, everything they do, as far as weather is concerned, is kept simple and it's kept color-coded. It's very simple to understand, it's kept color-coded, you know, so you understand, you know, that's the reason it's done that way, is so that it can be easily interpreted of what they're referring to on the charts. You know, fool me once, you know, fool me 92,748 times, you must be the weatherman. You know. Memory aid number 2, you go buy a new watch or a new clock and you put it on the mantle, it runs clockwise, that's good. That's the way it's supposed to run. But if you plug it in and it runs backwards, counterclockwise, it's bad. Clockwise is good, counterclockwise is bad. You'll see how that plays in a little bit later. First off, what the Coast Guard does not expect you to be a meteorologist. They don't expect you to be able to look at and make a forecast 3 or 4 days ahead of time. That's not what they're looking for. What they do want you to do is they want you to be responsible. So when you're getting ready to go out, they want you to go and look to see what's happening before you go out. You know, you want to check before you go out, monitor it while you're out and underway, watch for changes while you're out and about. You know, and what are we looking for? Thunderstorms, lightning, you know, a lot of wind, fog, and hopefully not too many hurricanes that we'll get involved into. They're not too much fun to be out in. But that's what you want to watch for. Today we've got a lot of different devices that we can use to get weather that we didn't have years ago. I mean, before we used to have to either listen to the radio or turn the VHF radio on, listen out there on the radio on the boat. But today you've got all kinds of things. Got apps on our telephone, on our phone, on our smartphone. We can pull up weather, you know, apps on that. We got the TV, we got the computer, the internet, all kinds of things to look at. The people that do the forecasting is the National Weather Service. Part of NOAA, NOAA's part of them. they do get their weather from them, and when we're on the radio or on the VHF radio, you can go to the different weather channels on there, and you'll get a tape recorded broadcast, and it's for different areas, and there's different frequencies or different areas that they broadcast on. So they're very specific about the areas that they're on. Very good weather, they update them. If you see this guy show up on the beach, you know, you don't want to go out. Jim Cantori shows up, you know it's going to be nasty, you don't want to go out at all, you know. But other than that, the Weather Channel is a great source to get information from. One of the best things to do with the Weather Channel is turn it on, turn the volume all the way down, put it on mute, sit there and look at at the weather maps and see what, you know, and look at them, and then you can go, oh, okay, so that's what's happening. Because by the time you get done tonight, you'll be able to go, oh, okay. You'll be able to figure out what's happening with the weather. Some of the sources that we have, you know, on the VHF radio, you've got the different frequencies that you have. You know, you have the weather channels, you go in there and you select weather, and you go to 1, 2, 3, right on through 7. And it depends on where you are, which frequency you're gonna get. Sometimes if you're listening on channel 16, the Coast Guard will come on. The Coast Guard will come on and say, we have a weather situation developing, you know, in this particular area. For more information, switch and listen on 22 Alpha. So you switch and listen on 22 Alpha, and you get the local, or you get the weather from the Coast Guard there. If it's bad enough, they won't wait, they'll give it to you right over 16. But, you know, if it's, usually what they'll do is they'll get switched, that way they're not holding 16 up. You know, you do have the internet and the phone apps we were talking about. The TV, the radio, the weather channels, they're all extra information that we can use. We can check before as we're planning our trip out and we're getting ready to go. The different NOAA weather frequencies, you don't have to know these, it's just what they are. These frequencies are given out. The nice thing is when you hit Weather Channel 1, you don't have to program it in, it goes right to that. Goes to that frequency. I mean, you know, there's no where you have to adjust the frequencies or anything. The thing you want to remember is these are all given to you 162.550 megahertz, channel 1, you know, megahertz. And so it's MHZ, and that's what it stands for. When we get into electronic navigation, which would be week 9, Kenny, he has a lecture that he does on electronic navigation. We'll be talking about different frequencies and all with the radios and stuff, but that's, you know, remembering megahertz with that is a big deal. Elements of the weather that we need to be aware of or need to know how they affect us, some of them are sun, the water, the visibility out there, and the wind, how they affect our weather, how they build the weather. That's what we want to look at. First thing is the sun, which affects everything else. You know, it provides the heat, the energy that warms the earth up or warms the water up. It's the heat source for everything else, for all the other elements. So it controls overall, I mean, most all the, you know, by heating the different areas up, a big section of the weather. Another big section is the water. 70% of the Earth's surface is water, so it's a big deal when you get, and it takes more energy to warm it up. So you know, it takes it longer to warm up, and after it gets warm, it takes it longer to cool back down. So knowing that can make a big difference when you're going down to the shore and you know that the water temperature is you know 70 some degrees, but yet the air temperature might be 60. You know, so you get out on the water and you know it's a big difference in the water and air temperature. Visibility. We've talked a little bit about it. You'll have more problem questions starting tonight and going on through the rest, you know, the next couple of weeks, talking about restricted visibility and everything with vessels. But visibility is a big point, and it's caused by the moisture in the air. A lot of it can be caused by other things, but fog, rain, snow, low-lying clouds, fog, depending on the temperature, you know, whatever it is. It can come down to dew point when you're getting in there, and when you're getting the, you know, more moisture in the air, it makes it really difficult to see. It's a big element that we have to deal with. Now, wind can be helpful at times, especially if we're running sailboats. You know, it helps push us along when we're looking for that. But it can also cause an increase in the sea swells, which can cause another problem, you know, when we're out trying to maneuver around and we're getting blown around, and, you know, we've got more waves to worry about, and can cause all kinds of issues with that. So here we are on Delmarva. We're, you know, some of the controlling factors for our area. You know, we have a lot of water around us here on Delmarva. We got water on 3 sides, man. So, you know, that's, you know, what we have. So we do have water. We've got the Chesapeake Bay, the Delaware Bay, and we've also got the Atlantic Ocean out here. Big parts of water out there, and they affect our weather a lot. If you watch weather as it's coming up, you know, it'll come up, and it's coming up on from the west, and it comes up and hits that Chesapeake Bay. Sometimes it'll go up and goes north instead of coming across the bay. Same thing as it's coming up the ocean. Sometimes it'll be, you know, you'll have some of that water, depending on what the temperature is. Sometimes it'll affect the way these lows, or, you know, storm pressures, or, you know, that'll be coming up, will affect how they affect us. Another area is our mountains off to the west. They can affect the weather. They can help direct the weather sometimes and slow it down, break it up. But they do help with controlling factors in our area. Probably the most prevailing is prevailing westerlies. You're going to see this is going to cause the biggest effect of our weather, because most of our weather comes from the west.
All your storms southwest, northeast, right? Didn't all your storms come southwest, northeast, more or less?
Well, they sometimes, yeah, you know, but you'll see them moving from westerly to easterly. Sometimes it'll be southwest to northeast. Yeah, but the prevailing westerlies are pushing the storms from west to east. That's the area that, you know, that we live in and that's what they have. Different parts of the globe have different types of wind characteristics, but ours is what they call the prevailing westerlies. One of the things you can do with that is, if you're watching the Weather Channel and you look out and you see a storm out in the, you know, down in Arkansas or something, you know, they're big weather down there, and you go, man, that's awful weather. It's really nice out here. And the next day day and a half, we've got that same weather that's coming right, you know, 'cause it's coming over us. So that's what you got to watch for. Another factor is the jet stream. It can come down and help direct the air masses. It can help with the, you know, with the way it flows down, and it'll help move an air mass along, you know, pushing it along from east to west. Can move it down from the south, or, you know, come from north to south. It can help bring a more cold front down, cold air mass down, or it may help a cold mass move up, or a warm air mass move up from the south. The Gulf Stream, big controlling factor in weather. You watch storms come up the coast, a lot of times that's what they're following, is the Gulf Stream. They'll follow that warm water because that's what they want. They want that warm water to feed the storm. It needs that warm temperatures. So as we move into weather, there's going to be a couple areas that we need to focus on and remember. The first one we're going to talk about is going to be clouds. And the next one we're going to talk about is temperature. And the next one we're going to talk about is pressure. Now, when we talk about temperature and pressure, we want to talk about temperature and not anything else. We're not talking about pressure at all when we're talking about temperatures. And when we're over here talking about pressure, we're not talking about temperature. We're talking about just pressure. In your booklet, you'll have this diagram. It's D039NG. This diagram right here, you will see on the exam, guarantee that that will be on the exam. So that's one, this diagram will be there. One of the things that they want you to know is be able to pick out some of these clouds. You have a listing of what the different clouds are. And main clouds that you need to be able to recognize on this diagram. The first one is cirrus, and that's the upper atmosphere, high altitude clouds. Today on the exam, they'll ask you, there's going to be basically on the exam, there'll be 4 different types of clouds that you could probably get questions on. But for the most part, you don't have to know anything other than be able to recognize where they are on that diagram. When we did our exam, they said, okay, cirrus clouds, what's the altitude range for cirrus clouds? And you had to know what the altitude range was, and you had to, you don't need all that anymore. They just, just that you can recognize, you see cirrus clouds up there, you know what they are. Stratus clouds. Here it's represented, I think it's number 6 on there on the chart.
Yes.
There's stratus, and then you got cumulus clouds. Cumulus clouds are the big white puffy clouds. They're not,
Until they become nimbus. No, they're cumulus until they become cumulonimbus.
Then they become cumulonimbus. They're low altitude building to high altitude, and that's the bad boy. He's the thunderstorm cloud. He's the one that brings the storm. Usually it accompanies cold fronts.
Mixing.
And you normally have fairly nasty weather with a cumulonimbus type cloud. So this is kind of, an idea of what they may look like a little bit. You got cirrus, stratus, cumulus, and cumulonimbus. When we talk about cirrus clouds, they're high altitude, basically they're ice crystals. It's moisture that's formed in ice crystals at high altitude, because remember, the higher you go, the higher, the colder it gets, and so when you get up into the altitude that they're at, it's very, very cold, and so they form ice crystals. They form what they call mare's tails, is another common name that you'll hear them called. Normally you'll see them in fair weather. You may see them preceding an incoming storm. They may be pushed ahead of a storm front, but they're normally, when you see them, they're usually fairly decent weather. Now, stratus clouds means layer. So you can have all different types. You can have altostratus, which is a high altitude stratus cloud. You can have, cumulostratus, which is they've cumulus clouds that have formed a layer of clouds. You have all different ones. So but anyway, stratus clouds, where you see stratus, they're usually layered. As they get dark, like they are showing here, they can produce some drizzle, depending on air temperature, like we had early this morning. You might get some snow flurries. Just depends on where they're at. Here's the cumulus clouds, big white puffy ones. They're the fair weather cloud. Usually when you see this, it's nice weather. And you go out and you got some cumulus clouds out and looking around, and it's really nice, and everything's nice weather out, and everything's going great. And you're watching, and all of a sudden the cumulus clouds start bunching up together. Instead of being big white puffy clouds, they start forming bigger clouds, and then they form something like this. And when they do, you get lightning. So, lightning and thunder is not something you want to be out there in or be able to watch what's going on. It can cause all kinds of problems. Usually when you have a cumulonimbus cloud, you'll have an anvil at the top of it. The nice thing about that anvil, if you can see that anvil up there, what that's going to tell you is what direction it's going. The anvil's pointing in the direction the cumulonimbus is actually hitting. So, or the storm is actually hitting in. So knowing that the anvil's going this direction, that cloud is moving that way. And it's being caused because the wind shear at that upper altitude is cutting the top of the cloud off. A lot of times happens with cumulonimbus clouds is they're so high you don't get to see the top of the cloud. But that can have, that's what, if you can, it can be nice. One term that you will need to remember is nimbus. Anytime you see nimbus in a cloud name, it means it's got precipitation. So if you see nimbus with a cloud, that's what they're talking about. They're talking about a rain cloud. Now, fog is nothing more than a low-lying cloud. It's just a cloud that's formed close to the ground. What it's happening is it requires moist air, and it needs a cooling medium. So where, the air is being cooled to where it can't hold any more moisture. So it's getting to be an area where you've got a low level cloud close to the ground. That's what's causing the fog. There's two types of fog that we'll deal with. One of them is called radiation fog. And radiation fog, you'll see that if you're going along especially in the early morning, going along and you look across the field. If you look out in the field and you look out there, across the field, you see the fog laying across the top of the field. And you're not having fog anywhere else, but you got fog out there across the field area. That's radiation fog. What happens is the heat's transferred away from the ground or the surface. The cool air coming in, what's happened is you've got that cool air coming up right by it. As it cools down, it reaches a point where the fog forms. And the fog forms when it gets closer to that dew point area. And we'll talk about that in just a second. But as it gets closer to that dew point, that's when you get the fog forming. Advection fog is what you see, what we deal with the most. It's what you're going to see probably more than anything. You've got warm, humid air moving over top of a cooler water surface. And so what happens is the cooler water surface cools that warm, humid air, and it forms the clouds over top of the ground, or over top of the water. When that happens, it makes it a heavy, deep fog. One of the problems with advection fog, most fogs will clear, temperature rises, wind blows, a lot of different little odds and things can happen, but that's the most, temperature rising, wind blowing. Advection fog may not necessarily leave if you've got wind blowing. It can still be there even with a little breeze. So you can still have advection fog. So you have to be aware of that. I mean, it can be, if that type of fog, what we run into. Remember the clouds? Those are the four clouds that we talked about. They're the ones you really need to remember. Cirrus, stratus, cumulus, cumulonimbus. Water vapor or humidity. We live in an area that humidity is really high all the time in the summertime. We have that. Warm air holds more water vapor than cold air. So a warm air mass can hold more moisture than a cold air mass. Cooling air loses its capability to hold that moisture. So as you got a warm air and it's holding moisture, and as it starts to cool down, it's not going to hold on to it. It fills that air mass up, and it's got to either come out of the air, or it's going to, after it gets up to a certain point, it's going to form condensation. And condensation can be in dew or frost or fog, forming a cloud. Also rain, snow, and sleet can be part of the condensation that it's going to form as it's cooling down. That's where that condensation comes from. It comes from cooling the warmer air. Relative humidity, at 86 degrees, this little bit of water vapor here is 28% of the air at 86 degrees. Same amount of water now, temperature drops. It's not, the water amount hasn't changed in the air, but the temperature's dropped. So now that the temperature dropped 68 degrees, that same amount of water is now 52% relative humidity. Same amount of water, as it approaches what's called the dew point, which would be 50 degrees, it reaches 100% humidity. At that point, the water's got to come out. It can't stay in the air. It's got to come out. It's going to form moist, it's going to form frost on your cars, mist, you're going to have the ground's going to be wet, when you go out, you'll see, mist on your top of your car. That's going to be the dew point. It's where the temperature of the air is saturated. And when it does, it's going to form condensation. Doesn't matter, but anytime it reaches that dew point, it's going to form condensation. When you hear the weatherman talk about on the TV or on the radio, and he goes, the dew point's 70 degrees, that's a lot of water in the air. It's really humid. So, but like you've got a dew point at 30 or 35 degrees, it's going to be low amount of humidity in the air. Temperature and pressure. When we go, we're going to talk about these, we want to make sure that we keep them separate when we're talking about them. First thing we're going to talk about is temperature. One of the things with temperatures, you got cold air, you got warm air. You can have an included front and a stationary front. We'll talk about all those. But that's when we're talking about temperature. Temperature, we're talking about an air mass. An air mass of cold air or an air mass of warm air. And all it is, it's a body of equal air of temperature. A warm air mass is just warmer than the area that it's going over, that it's replacing. Cold air mass is just colder than the area that it's going into or replacing. So that's the difference between warm air mass and you can have a warm air mass that's 30 degrees if it's replacing 20 degree air, So, it would be warmer than what's there. In between where the new air mass is coming in, replacing the existing air mass that's there, along that area is what's called a front. That's what these represent. Warm air front, cold front, stationary included. They are the leading edge of the air mass. So where the air mass is coming into taking over the cold, warm air mass taking over a cold air mass would be this one. A cold air mass coming into a warmer air would be this one. That's the symbols. One of the things that you need to be aware of are air masses. They're classified according to where they originated. One of the things that you won't see on a regular weather map, you may see it on a NOAA weather map or National Weather Service map, but you're not going to see it on the Weather Channel. You're very unlikely you'll see this. These are the air masses of how they're formed. What you won't see is you see that something like this is you won't see these named as warm front or cold front, but it's kind of easy to figure out what they are. You have a continental polar. Continental, formed over the land. Polar, cold. So it'd be kind of easy to remember, how what it is. You got maritime polar. They're formed out over the ocean or over the water. Maritime, polar being cold. The difference is the continental polar is going to be dry air. Maritime polar is going to probably be a very moist air. It's going to be a higher humidity. Then we got continental tropical. It's formed over the land and warm air mass. Got maritime tropical, which is formed over the water, warm air mass, tropical. And you've got Arctic. One of the things that we have to deal with this time of the year is the Arctic air mass that's coming down. You won't see these on, like I say, on the Weather Channel or weather forecast things or anything like that. You may see it on a National Weather Service map or something, but you won't see it on a regular weather chart. What you will see are warm fronts and cold fronts. They'll say, they'll show you the front lines. They don't show you the actual air mass. And what's you're seeing, when you see that, this is a warm air front. And this is warmer air back here and colder air up here. The direction of the sun, you got little half suns for the direction for our warm air mass. Makes it easy to remember. Suns, you know, think of, you know, nice setting sun, nice warm temperature to be out in, sitting out on the beach. So we have our warmer air moving in the direction that the little half suns are pointing. That's the direction that the air mass is moving. You have the colder air on the top, the warmer air is behind it. Same thing on the bottom. Here is a cold front. It's got little icicles sticking out. Think of them as icicles, and they're blue. You know, when you go into the bathroom and you turn the blue faucet on, it's cold water. You turn the hot faucet on, it's red. You know, it's hot water. So it's easy, you know, they make it so the weatherman can remember that when he when he's up there trying to color, you know, the colors on the fronts. Here we have colder weather back here, colder air mass, a warmer air mass. It's moving into the warmer air mass. That's all it is. That's all they do. These are the 4 different types of fronts that you can see on the weather chart. And you will have the warm air mass we just talked about. Remember that, you know, they're half suns. They point in the direction that's flowing. Cold air mass, well, icicles pointing in the direction it's going. Cold air is behind it. Warm air is on the other side. Stationary front. Cold air mass was moving that direction. Warm air mass was going that direction. They've hit. You had 2 moving air masses. They're hitting and they're competing against each other right now. They've beaten each other up. Probably not a good place to be along that little front. Probably going to have some pretty nasty weather. This one here is an occluded front. And you got half suns and icicles, and they're both going the same way. And what an occluded front is, and I'll show you a better diagram, but what it is a cold air front that's overtaking a warm air front that overtook another cold front. And so what it's doing is it's coming in, it doesn't actually get rid of the warm air mass, it pushes it up into the atmosphere. It actually rides underneath of it. The warm air mass is sitting on top. So that's what that's what an occluded front is. Again, this is a warm air front. So what happens, warm air holds more moisture than cold air, right? So what's happening as this warm front comes up and it's hitting this cooler air, it's cooling some of that air in the upper part of the atmosphere. It's forming more clouds. It's probably be a lot more cloudier with a warm air front. But the thing that you'll have with warm air fronts is you'll have steady precipitation. You don't get a lot of wind. You don't get a lot of, you know, of bad weather. Normally whatever it is, it's pretty stabilized weather. Whatever type of weather you have, it's going to be pretty stable along a warm air front. Cold air, it's coming in, warm air is over here, it's pushing in, warm air pushes up over top of the cold air. Again, warm air is holding more moisture, cold air comes in, pushes the warm air up into the atmosphere, it cools it down, it's going to form rain. Differences in cold front pushing the warm air front up there like that is it forms rain. It normally makes a worse type of storm. It makes a heavy storm. You normally get this is where you get the cumulonimbus type clouds, or one of the areas that you can get them. It pushes the warm air up into the atmosphere. You normally get heavy rain, you get wind, you get all kinds of different types of storms. Very, very bad. But as soon as that front passes, with a cold front, usually it clears. Cold fronts don't last as long. Cold air masses usually don't stay in an area as long as warm air. Warm air usually settles more, you know, it's usually there longer. And although it's more stable, it can be cloudy. But a cold air mass usually is clear, but not along the front. Along the front, it can be pretty bad. Doesn't have to be, but it can be. A stationary front, like I was saying, you got a warm air that's headed this way, cold air hitting this way. And what happens is they sit there and beat each other until one of them gives up, and pushes the other one out of the way, and then you'll push them, you know, goes on. Usually you'll see the symbols, it'll be red, you know, a red, blue, red, blue. The nice thing about these symbols, the way the symbols are done, because a lot of times, you know, we got good color TV now, but on a weather chart, you don't have color, it's all done in black and white. So you get a black and white printout. I can still tell which one is the warm front, or the, you know, the warm air front, and which one's a cold air front, or which, you know, which way they were heading and everything, because I can look at it and you can tell by the shapes, you know, what we have. Now, an included front, here we have the cool air, the warm air, and another cold air mass coming in. Here we had cold air, the warm air mass came in on top of it. It was coming up, and then we had the next cold air front come in, and it pushes the warm air front right on up into the atmosphere. The warm air front does not dissipate, it's still there, there's still a warm air mass there. It's warmer, but it is not on the ground anymore. You got just the cold air masses. What the airs are telling you, the directions they were headed, normally along that front, it's really bad weather. It's where you get your bad squall lines, your bad thunderstorms, you can get your tornadoes and stuff, and everything like, all that kind of storms can flow like that. That's temperature. Warm air masses, cold air masses. Really difficult. Now pressure. We're going to talk about different symbols, how they measure it, what the standard atmospheric pressure is, what the isobars are and how they work with the wind. And we're going to talk about cyclones and anticyclones just a little bit. The symbols, they keep pretty simple. You can see on the chart back here, there's an H, there's an L. H is high pressure, L is low pressure. Makes it, you know, really easy to remember. Standard atmospheric pressure. These three numbers are three numbers that you will need to remember. You will see it in a question, either all three of them in a question, or they may only have one. 29.92 inches of mercury. 1013.25 millibars of pressure. 14.7 pounds per square inch. They're all exactly the same pressure. They're just three different measurements. If you see a question that has all three of those numbers in a question, A, B, C, and then D, all the above, you know that's D, all the above. But if you read it and you see 29.92, you go, oh yeah, there it is, 29.92, that's the right answer, pick A. Remember those three, because sometimes what they'll do is they'll put three different numbers in there, or four different numbers, and only one of them is the actual one that is an actual pressure at sea level. This is a reference pressure for sea level. Other than that, it don't mean a whole lot. They're just, you know, not for us. It does if you're flying. A barometer is an instrument that's used to measure the pressure. And one of the things you want to do is you get a nice barometer, you want to make sure it's got stormy, rain, change, fair. Make sure it's got all those nice pretty words written on there. That's really important. No, I'm just kidding. It doesn't, not really. They don't mean anything. They just put those on there to sell them, make them look good. Because it doesn't really matter what those words are out there. You know, you come up here, you got 29.92. This is where, right here, is standard atmospheric pressure, right here. What's important is to watch. You take and you set that little dial right there. You set that one movable hand on your where the needle is, or what the actual pressure is, and then watch what's happening. Is the pressure going down? Is pressure coming up? pressure's going down, I got a lower air pressure coming in. If it's going up, we got higher air mass coming in, higher air pressure coming in. So that's what's important to know, is which way is it going? Is it coming, is the pressure, is we getting a higher air pressure in or a lower air pressure in? It's important to know. And then how fast is it coming in? Is it dropping really fast? That means I get closer to the storm, you know, which is more important than going up. If it's a high air pressure, I'm not as concerned about that as much as I am the lower air pressure, which is the stormy side of it. So we have high and we have lows. With a high air pressure, normally you have cool, dry air. Good weather. Go down, enjoy the nice weather. Drink a beer, get nice, feeling good. You know. That's what high pressure would be. Low pressure, on the other hand, when we have a low pressure, it's warmer air usually, very moist air, but usually bad weather. It's going to bring with it rain and wind and normally not good weather at all. So that's the difference between high and lows. Another big difference in high and lows, with the high being cool and dry, bright and sunny weather. With a high pressure where you see that H and you see the low on the weather chart, that's where the center of the high pressure is, or the center of the low pressure is. Where the center of that high pressure is, it's pulling air down out of the atmosphere. It's bringing air down to it, to where the high pressure is. It's pulling moisture out of air out of the upper atmosphere, bringing it down. And where it brings it down, and it gets down to where that high pressure is, the air is going to come out and go along around it clockwise around a high pressure. So the wind is going to go clockwise around the high pressure, as it shows. A low pressure takes that same air that's coming out of the high, pulls it towards it, and it's bringing all the air mass, all the air that's around it, pulling it into the center where that low pressure is. It pulls it into that point in a counter clockwise wind rotation. Pulls it into the center of the low and then pushes it up into the atmosphere. So it's pulling all that air in and pushing it up into the atmosphere. So if it's pulling warmer air mass in, pushing it up into the atmosphere, it's going to cool it as it goes up, and that's where you're going to get your bad weather, your rain. High pressures clockwise, lower pressure counterclockwise. High pressure is from the center and out. Low pressure is from out coming into the center. And counterclockwise rotation. Anticyclones. You won't see much on anticyclones anywhere. You won't see anything on the exam or anything about it. But because they need to mention them, I'll just mention it. It's basically a high pressure area, and usually it's going to be a clockwise wind. You'll have clearing skies, cooler air, drier air with it. It's not really much of a problem, you know, around an anticyclone. Now, isobars. What isobars are, if we have our high pressure here, 1028 in the millibars, that little circle right there is just a group of weather stations, and they all reading 1028. And they call in and they say, okay, we got 1028 millibars, we got 1028, and they draw a circle. They connect all the weather stations together. That's what forms the millibar, or the area that what they show. Very seldom will you ever see a circle like that, you know, with an isobar. But here we have this little area here is the high. The next one out here is 1024, and this one out here is 1020. You can see that it's getting less pressure as we're moving away from the high. The wind is going clockwise out of the center of that high, clockwise around it. Here we have a low pressure, 1012 millibars, 1016, and then it goes out here to 1020. So the wind is coming out and coming back into the low. It's going around in a counterclockwise rotation coming into the center of that low. All an isobar is just all these little areas here is 1016 around it. Now what you'll probably see is more something like this. This is Europe, but this is an isobar line. And it's showing you that isobar line there is 1015 millibars. You know what that is. So the isobars close together, you have strong winds. The further they're apart, lower winds. Here they have a little cold front coming in, you got a warm front coming in. And you can tell a little bit of what's going on. Included front, being done in purple. So, pressure and wind. Here's how it works. Here we have a low pressure here and a high pressure here. Isobar line here of 1008. Isobar around the low here is 996 millibars. The wind is going clockwise around the high, counterclockwise around the low. What's important about the isobars, other than knowing that they're connecting, same pressures, is I know this is a low pressure. I know this isobar is here. I know that if I'm standing right here, the wind is going to be coming out of the northeast, north-northeast. If I'm over on this side, the wind's going to be coming out of the south. If I'm over here, wind's out of the north-northeast, or northeast here. Northeast coming down this one, northeast. So I can tell because of where the low or the high pressure is, what direction the wind is going to be. Now another thing I can tell is how much wind I'm going to get. I don't know the exact speed of the wind, but I can tell whether it's going to be a lot of wind or none, or very calm, by how close the isobars are. The closer spaced the isobars are, the more wind it is. So if you turn on the weather and they've got isobars on the weather chart, on the local weather, it's a lot of wind, because they don't put isobars on the chart unless there's a lot of wind. They go, oh, look at these isobars, we got a lot of wind coming up here. They do that just to impress everybody. I really think that's what they do. But if you go to the Weather Channel, you might see the isobars shown, or you might see a weather chart with the isobars on it. And if you do, that's what we're looking at. Here we have the center of the low. Remember, it's counterclockwise wind. But as we've gotten here, you can see how close the isobars are. You probably got a lot of heavy wind there. It's probably 20, 25 knot winds. Probably pretty heavy wind. We get down over here in our area. That's 1012. That's 1012. They're probably going to be fairly calm or very gentle winds over our area, because the isobars are not close together, they're spread out. So that's what you're looking for when you look at isobars. I don't need the weatherman to tell me it's going to be windy. If I look up there on the weather chart and see isobars close together, I know it's going to be windy. A couple of terms Coast Guard wants you to understand and know. One of them is called veering winds. A veering wind, if you're facing into a veering wind, you face into it and it starts changing in a veering is clockwise. Veering, when it starts to change in a clockwise direction. So if I'm facing into the wind, and the wind changes from, say, if I'm looking to the west, and it starts going northwest, north, northeast, and it's going around, coming back around, going to my clockwise direction. That's the direction the wind's coming from. That's called a veering wind. If I'm looking to the west and it goes the opposite direction, now it's going to the southwest, to the south-southwest, to the south, and it's changing, going that direction, it's going in counterclockwise. That's called a backing wind. It doesn't mean that the wind is going counterclockwise, or that the wind is going clockwise. It's just the direction, the changing of the wind direction hitting you. The direction it's affecting in your area. A lot of times what happens with a veering wind or a backing wind, it depends on where you are with a low pressure. That's what I'm primarily interested in. And how's it changing, because it's telling me a lot of things to do with the storm. You know, which way is the wind coming from, which way is the low pressure, and I can tell a lot of that by the direction of the wind. So that's basically what we're looking at. It goes to the left, or counterclockwise, it's backing, goes to the right, it's veering. Again, it doesn't mean that, you got a clockwise wind, it doesn't mean the wind is going clockwise, it means that it's changing direction, hitting you in a clockwise manner. That's two more terms the Coast Guard wants you to know. One of them is land breeze. A land breeze happens primarily at nighttime. It's a localized weather effect. It's not something that the weatherman's going to be able to forecast. He's not going to tell you about it. Unlikely that they're going to tell you on the weather, they're forecasting weather. Well, if you go down to your boat and go down to the dock, you're going to have a land breeze tomorrow morning. They're not going to tell you that. Unlikely. But what happens, I go down and I'm going to go fishing off in the ocean. And I go down to Ocean Studies. I get down there, 3:30, 4 o'clock in the morning, get down in the boat, go and say, okay, we're ready to go. Get down there, and the forecast is for a beautiful day, light winds. And I get down there to the boat, and all the flags on the marina and on the boat, they're going, fluff, 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 fluff. Just, wow, wind blowing. They said it wasn't going to be any wind. But what's happened is, that's a land breeze. What's happening is the water is warmer than the land. The land's cooled off at night. Say it was, normal temperatures during the day is 75, 80, but at nighttime our temperatures drop to 55. So our land mass is cooled off during the evening, because it cools quicker than water does. So the land temp is colder, and now I've got air moving off of the land going back to the water, causing a land breeze, because it's going from the warmer, or from the colder air mass, or the colder mass to the warmer mass. That's the direction the wind's going to go. We get out in the boat and we go out of the inlet, we go about 4 or 5 miles offshore, and all of a sudden there's no wind. Because that's as far as the wind went. It just goes out and does like a circle, and comes back up and goes back towards the shore, rises up and comes back, forming a little pattern. That's called a land breeze. The land is cooler than the sea temperature. Because overnight, although the temperature's dropped, water doesn't cool. If it was 75, 80 degrees, maybe the water temperature might be 68, and it hadn't cooled. But the land mass might be 55. So the air, so it's blowing from the warm air to the cold air, to the cold air to the warmer air. Daytime, we've been out fishing all day. Getting ready to come in, 4:30, 5 o'clock, coming back in the marina. Beautiful out, we get close to the inlet, and all of a sudden the wind picks up. Only this time, instead of blowing out, it's blowing in. Because what's happened is our water temperature stayed the same. Our land mass is warmed up during the day because of the warmer air temp. Sun's heating and warming the air up, or warming the ground up. So now we've got the cooler air coming off the water, going back to the land. And it's causing a sea breeze. What you want to remember is they're named for where the wind is coming from. This chart here depends on where you're from. Beaufort wind scale. What this scale is for is so you can predict what the wind is doing by what the characteristics is on the water, or characteristics around you. If I look at that chart, and I can look at there, and I can just feel a little wind on my face, and rustling some, some leaves around, just a little bit of stuff around, not a whole lot moving around. I look over here, it looks like it's a light breeze, maybe 4 to 6. If I look out there and I got some white caps, I can go over here, water on, you got some down here, Monarch Way, some white caps are common, here's many white caps right in here. I can look over here, 15 to 20, somewhere in that area, depending on how heavy the wind, or how heavy the white caps are, how heavy the wind's blowing. I can get an idea of what type of wind I've got. That's all it's for. It's to help you estimate what, because of the winds, the visual observation of what the wind speed is. It was a scale they made up, works great. We talked about cold fronts and warm fronts. This here's another picture of a cold front coming in. We got cold air and warm air. That's what it looks like on a weather chart. You got the weather front here. You got the cold air coming in, warm air over here. Along that front, you normally have gusty winds. You've got a drop in temperature. Sometimes because of the front, you get the rise in the warm air going up across the cold front. You're going to have hail, thunder, and lightning, the cumulonimbus type cloud that forms, form up there and make that happen. Thunderstorms, pretty common along the cold front. With the warm air, it's warmer over here going that direction, warm air here going up. You see cold air, it runs up and it overrides it, makes it warmer, gets rid of the cold air. As it does, what you'll see is an area of clouds. You see the clouds forming in the warm air front because warm air holds more moisture than cold air. And because it holds more moisture, as it cools, you're gonna have more clouds. One of the things that can happen along that front is you can have rain, but it's not gonna be heavy rain, it's gonna be steady rain. Showers, gonna be gentle, gonna be steady, it won't be anything of a big, hard nature. You don't get a lot of wind with that. Normally it's followed by, a little bit of warmer weather after it passes. One of the things that can happen out on the water is what they call squall lines. Squall lines can be really nasty. They can be 5 to 6 miles across. They're usually in front of the cold front, passing in front of the cold front. Normally what happens, you'll have the hail, the heavy precipitation, strong straight winds, water spouts, tornadoes, they form along with the squall lines. You'll see them, form across waterfronts, and if you're listening on the radio and they give you an announcement, there's a squall front coming through, pay attention to where it is, because it can get nasty where you're at. It gets nasty in a hurry. That's the problem with squall lines, is when they pop up, you don't know. It can be really, really bad. And our bad boy there, the cumulonimbus cloud, again, just kind of touching on it again. What it's doing, remember the animal's pointing in this direction, so that's the direction it's traveling in. It's pulling this warm air or the air up inside it, and it's cooling it down. It's causing wind and rain and hail, could cause some snow or whatever in there. It's normally nasty weather along a cumulonimbus cloud. Remember, cumulonimbus is the thunderstorm or rain cloud, big heavy thunderstorm, lightning. Bayes ballot law. Something that we don't use a whole lot anymore, but it's something that could be useful if you're out and you're sailing along, down the coast or something. You know that there's a low pressure in the area, there's a storm in the area, and you want to know where it's at. So if I'm going down, I'm taking, I face into the wind. I'm gonna take and put my face into the wind and take it, and wherever it is, wherever I'm on the boat, wherever the wind's hitting me, that's where I'm gonna look. I'm gonna look in that direction. I'm gonna take my right arm up, and I'm gonna point straight out at 90 to 100 degrees. I'm pointing to the center of the low. the wind's hitting me in the face, I'm pointing to the center of the low pressure. So what good is that by itself? Not a lot. But what happens is say, okay, so I take that and I say, okay, dry it down, figure out what direction the wind, about where the center of the low should be. I know approximately how close I am because of how fast the barometer's dropping. So I can take and look at that, but then what I want to do is now I know where the center of the storm's at. I'm going to take in about another 15, 20 minutes maybe, or half an hour, let the wind hit me in the face again, point out to where the center of the storm is. So is the storm back this way, or is the storm out this way? Am I headed into the storm, or am I headed away from the storm? That's what I want to know. So I can tell that by using Bayes' Ballot law. Knowing where it is, I can take it face into the wind, take my right arm out, 100 to 110 degrees, 190 to 100 degrees, and that's pointing to the center of the low pressure. If I know that, I also can, if there's a high pressure in the air, I can tell where the high pressure is. Take my left arm out, and it's the same thing. Bring it right off to the hurricanes. This is Joanne. 2019. Pretty nasty storm. Pretty well developed eye. Pretty heavy storm coming around. The hurricanes, what the Coast Guard wants you to know is how to navigate in them. Yeah, right. Yeah, right. They're called tropical cyclones. They're also called typhoons, depending on where you are in the world. If you're out in the Pacific Ocean, that's what they're called, typhoons. 64 knots or more is a hurricane. Counterclockwise rotation around the hurricane. Counterclockwise is bad. Counterclockwise is also around the low pressure. So because of that, I know counterclockwise wind rotation, I know that it's low pressure. The lower the pressure, the worse that storm is. Where the center of that eye tracks is what I want to be able to know. So we turn on the Weather Channel. And they've given us their prediction of where the storm's going. They say because of this one, it's going this way, and because of that, it goes this way, and because of that, it's going up here. Well, they don't have any idea yet. Not until it actually gets there and starts actually tracking, and they can tell because of where the other pressures and stuff are. You can tell them. Actually, they do a little better job than that. This is NOAA, the National Weather Service. And what they predicted here, this is where the center of the storm is right now, Sunday at 8 p.m. And so they're predicting where the storm's going to track. And you can see how it's got like an area that spreads out because they can't tell exactly where it may go. So what they're doing is they're predicting where it may be Wednesday at 8 a.m. It may be in here, but it could be anywhere along in that little window they've got there. Most likely to the center. So that's what you want to watch for, to have an idea of where it is tracking to, and have a good idea of how, where it's going, try to stay away from where it is. You'll hear different terms. You'll hear tropical depression, 34 knots or less. We have a lot of tropical depressions, especially along the coastline here. And 34 knots is a lot of wind, but it's doable if you have to be out there in it. Not where I want to be in, but then you've got tropical storms. They're from 34 knots, 63 knots. Usually when they get into these, sometimes they'll name them. You know, normally a depression, they don't name, they normally just give them a number until they get up to the tropical storm area. And they get in the tropical storm, that's when they give them a name, because they figure they're gonna become a hurricane, and they want them, you know, name them before they become a hurricane. Then they become a hurricane, 64 knots or more. When you get to a hurricane, you've got different categories of hurricanes. You got 1 through 5, and you don't have to remember this for the exam. This is just for you for general knowledge, so you know if they're talking about a Category 5 hurricane. I'm talking about just not wanting to be anywhere near it, compared to being with a Category 1, 64 to 82 knots. Yeah, well, it can be bad. That's not. I don't want to be in it either. I'd rather be, at home. But one of the things to remember is here in our area, June through November is the hurricane season. And you go to the West Coast, it's, they've got, it's May 15th, and, other parts of the world, they have them, whenever they show up. So what we have here is if we have a really bad storm in the wintertime, what do they call it? Nor'easter. They don't call it a hurricane. It doesn't get named or anything. You have a nor'easter coming in. Be aware, gotta be watching this nor'easter. You can have winds with a nor'easter as high as 64 knots or more. I mean, that happens. So you gotta be aware of what's going on. Different parts of the world, different areas, they have different seasons. So, October through May for Indian Ocean. All year long in the Pacific, Northwest Pacific. What do we want to do when we see a hurricane, or we know that we have been told that a hurricane's coming? Well, sometimes, we can make it, we can go down and get the boat ready, or we know we don't want to be out. I had a friend call, one of the guys went through the class, got his license, he calls, he says, let's go fishing, I've got a charter that canceled out. He said, we got the boats all ready to go, let's go. I said, oh, okay. We went, there was 1, 2, 3, 4, it was five of us that went, 4 of us were captains, licensed captains on the boat. Out we go. Out of Ocean City, August 20th. So off we go. Out we went. It was a little rough. Didn't really realize how rough it was. This has been a few years ago, by the way. I didn't really realize how rough it was until I got home and had the film developed I had in my camera, because I, was taking pictures of, people catching fish and everything. I'm standing down in the cabin taking pictures of them reeling fish in. Really, I get home, get films developed, and the back of the boat, it's straight, but the ocean's like this, almost a 45-degree. Yeah, it was rough, and it was, and you look at the next picture, and it's just the opposite, and so it was really bad. 2 days later, hurricane hits Ocean City. It was nasty, but we had increased sea swells. The sea swells were nasty out there. I mean, it was high. There were long period in between. Really rough ride. One of the very first things you're going to see if you're out and around is going to be increased sea swells. The sea swells will get larger. They're going to become more numerous. And why it does that? It's the surge in front of the hurricane. That's what's pushing that sea swell. It's a surge, and it's pushing that sea swell up. So that's going to be one of your very first signs of a hurricane. The next thing you're going to notice is a drop in atmospheric pressure, a drop in your barometer. It's going to start dropping, and it's going to drop and not go back up. You can get what's called a pumping barometer in between here. A pumping barometer happens if, when you look at a hurricane and they've got those bands swinging out around away from the center of the hurricane. As those bands go over you, pressure drops, and the bands go out and it clears back off, the pressure goes back up. It's what's called a pumping barometer. But as it gets closer, you get a steady drop of barometer. Normally increased winds at that point and rain, although you don't get torrential rain, starting to get rain. Cirrus and cirrostratus clouds start to develop before you'll have the rain and all that coming. That's one of the very first, signs you'll see along with your swells. You'll see that in behind. What happens is they start to form, then they start to form a layer, and then they start to form lower as the clouds start to drop. As it starts to approach even closer, that's when you get the torrential rain. Just a seawall, of rain, just heavy, just straight rain. You can't even hardly see through it. It's raining so hard. Rapid fall of the barometer at that point. It just, boom, just starting to drop. You can sit there and probably watch the needle drop instead of waiting for it to come back and see which, if it's dropping. You probably can almost see it drop. At the eye of the hurricane, not where you want to be, but if you do happen to be there, what happens is you're going to have very low pressure. It's going to be the lowest of the pressure for the hurricanes, where the lowest pressure is. Also, the seas are confused because you've got the wind, you've got the counterclockwise rotation. It's pulling the wind, waves in, waves are blowing one way, the wind's blowing, and it's going to be really confused seas because the seas don't even know which way to go because it's right in the center. Am I going this way or I'm going this way, right? So they're really pushing around. If you're in the center of the eye and can look up, you'll probably see blue skies because it's going to be an open air if it's a really well-formed eye, because you can see right straight up. It's just like a tunnel. Probably can see the blue sky above it. If anybody does that, let me know. Just send me a text or something. It'll be fine. After the eye, everything changes. Everything switches to the opposite direction, and it just goes in the opposite direction, and you get just reverse of everything, just the way it happened. As it goes away and it goes up the coast, you still have the rain, and then the rain gets lighter, and then you still have some sea swells, and then all of a sudden the sea swells start to drop off, and that's when you know the storm's up the coast, or out to sea. So navigating the hurricane, what we want to know. What we need to know is the direction of the storm. Which way is it heading? We need to put the storm into quadrants, and we need to know not only the direction, but the speed that it's traveling. Because that tells us which way we can get. Do I want to go in front of it, try to get around it, or do I want to go behind it and try to go around, behind the backside? Or do I want to stay tied up in the slip in the harbor, which is where I'd want to be. I don't know. Most people, So here we have a hurricane. We have the eye right here. This is the track of the storm. That's the direction it's traveling. And so when we look on a chart, they'll have the hurricane. They'll show you what direction it's actually traveling. That's what you want to know. What we do is that line right through the center, this is what they call the dangerous semicircle. That's the dangerous side of the hurricane. This is what they call the navigable side of the hurricane. You can go. Again, just let me know. I'll be fine. So we want to take and divide that into quarters, into quadrants. And when we divide it into quadrants, one of the things we want to look at is where is the worst. This front quadrant, the front right quadrant, is always the worst part of the hurricane. That's where it has the strongest effect, the maximum effect of the hurricane, the strongest winds, the most organized winds, the most organized sea, and everything. That's where it's at, is in that northeast quadrant. That's the worst area. When that area hits the ground, when it hits the land mass, that's where most damage is done. This back here would be the next most dangerous because the winds are still coming up, they're forming, they're still pretty well in a, wind with the right direction and everything, they're with the wind and they're with that. This is the right rear, it's a strong wind and gust and they're really, really bad. You have a really, almost as bad as the front, not quite. The next is this segment right here, the left front. That's another bad section hitting the land. You gotta remember, it's got a lot of sea surge with it. Although the wind is going the opposite, now it's coming around and starting to go the opposite direction. But you do have a lot of storm surge, you have a lot of rain, pushing up on that side, so that can be a pretty nasty point. This one here is where the weakest of the effects are. So if I'm out and I get caught in a hurricane, I want to get to that segment, to that quadrant, and then work my way out of the hurricane. Because this area here is going to have the least organized wind, the least organized wave section, wave push. It's going to be the least. And why? Let's look at a hurricane here going up on the coast here, coming up in north South Carolina. It's coming in and it's traveling at 20 miles an hour on the track it's supposed to be on. They estimated the winds to be 100 miles an hour. So if it's going this direction and it's got 100 mile an hour winds and it's tracking at 20 miles an hour, that means the apparent winds are 120. 120 mile an hour winds in this area, down here, apparent winds because it's moving away from me would be 80 miles an hour. 40 mile an hour difference in apparent winds. That's a big difference. So that's where I'd want to be, is down in this segment here. If I had to be there. That's the big reason for knowing which way to go and which way to go. They go through and they show you all kinds of things, which way you want to maneuver and everything, and there are pictures in the hurricane. If I'm not going to be there. We're going to try not to, as best we can. So, when we have our weather, what we want to look at is what the Weather Channel is telling us. They're going to give us an advisory. They're going to give us an advisory of, storm approaching or, winter storm approaching. This is just an outlook or an advisory. It doesn't mean that it's actually here. It doesn't mean that it's actually happening. It doesn't mean that it's going to happen. It just means that it could possibly happen. And they just want to make sure you're aware of what's going on. Time to start planning, making sure you got the snow shovels installed out for the snowstorm, or making sure that you have
Life
extra
jackets.
lines, and get the life jackets out. The watch. When you get to the point where they're saying that we have a watch, that means the conditions in the area are there for this to happen. Doesn't mean it's happening. It just means that everything's happened. The conditions are there. It probably is going to happen. You're probably going to see this, some type of bad weather in this area. It's not necessarily something you got to be, it may or may not happen, but you're more than likely it will. That's what a watch is. Very favorable. You want to make sure you got your life jackets out at that point, and your Grundens. Make sure you got them. If you're out on the boat, you get everything, all your, bad weather gear out. The warning. If they come out and give you a warning, that means it is happening in the area. It's been cited. If it's a tornado and they say it's a tornado warning, that means either a tornado has actually been cited, rotation has actually been cited, or it's been seen on the radar. You've got rotation on the radar. There's something going on. there's something actually happening. That's what they do. You have the advisory, then you have the watch, and then you have the warning. You know, we watch for the warning. Different types of watches you can have. I mean, it just depends on where, you know, you flood watch, hurricane watch, thunderstorm, tornado, tropical storm, winter storm. All those are things that we need to be aware of. When they say that you've got to watch, this was things you want to use. You want to start getting ready, preparing yourself for these conditions. Hopefully they don't happen. You know, so you want to watch for the warning. When they say there is a warning, that's when you have the hurricane, where you could have the 2 feet of snow. They might be calling for these different things, and you need to be ready for them at that point. Now, what you want to do is remember what the Coast Guard wants you to be able to do. They want you to check before you go. They want you to look at the weather forecast, look at what's going on, look at that weather map, and look at it yourself. And don't just listen to the weatherman. Look at what, he might be telling you, but look at what, some of them, I think they get paid extra to tell you that it's really going to be nice, pretty down to Ocean City. And you go down there and it's awful. Because, if they tell you it's going to be pretty and everybody's listening, they're going to go to Ocean City and spend more money. So I think that's, one of the things they do, but I don't know. But monitor if you go out and you go out and it's supposed to be pretty weather and you go out and you're out there and you're, normally we go out, we don't go out for an hour or 2 hours. We're going out, we're spending 6 to 8 hours, 10 hours, 12 hours, sometimes, longer, sometimes out. And when you're going off, especially if you're going offshore, so you've really got to be aware of what's happening. Stay on, monitor what's going on out there. Watch what's underway. Watch the sky, not just monitoring what they're telling you on the weather forecast. Watch what's going on. Watch your barometer. Watch the sky. Watch for cloud formations. If you see a bunch of clouds start forming, you know that it's not going to be pretty. So you need, maybe time to start maybe heading back in. Watch for the changes. And listen on the radio, your VHF radio, and you got your smartphone. Everybody's probably got apps on their weather apps on their phone. I've got like 6 different apps, weather apps, and I pull them up and I'll look at one, look at the other, and look at the other. And if we're going to a different area, if we're going down the coast or something, I may want to know what's happening, down there. So I want to look, I want to forecast. I want 3 or 4 days out. I don't want what's going on right now. I want to know what the winds are going to be and what the sea conditions are going to be and like that. So, you can go, there's some really good ones out there. If you're listening on the radio and you got your AM radio on, you got your AM radio out there and you're listening to some old AM radio music, and you're listening to the, sports or something, and you're listening to it and you get static on there, there's nothing, all of a sudden you get come down through the radio and you go, what was that? And you look around and you see some clouds building up in the distance. It may be thunderstorm clouds. It may be lightning you just heard on the radio. So listen for that. Listen for different things. Thunderstorms, wind can build up. It can cause some big issues. Fog, you can't see. Hurricanes is what we want to avoid. Hopefully we'll stay out of their way. We know before we go out. We think we're paying more attention to the weather than what some of us did. And we'll know what's happening before we go out. You go to the Weather Channel, you look at the surface maps, pull on, just go in there and look at them and look at what they're telling you. Here we have a high pressure, so we know the winds are clockwise around the high pressure. Here's the pressure, so we know it's clockwise. So we know it's probably going to be going around like this direction around that isobar line. Over here we have a low pressure, so they're counterclockwise. You got a low and a low with a warm front, an included front. It makes sense because you got a little cold pressure there, a little warm pressure, you got an included front right there. Here we have a cold front pushing down out of the mountains, a bunch of different lows here, readings with a high. I bet this weather in here is not really good up in the upper part of New Mexico. And you get up in here, you got a nice high, clockwise rotation, clockwise rotation out here. And you can tell there's a warm front here, you know, cold front pushing down, stationary front. Probably right here, over us, probably nice weather, might be nice to be able to go out. You may see a weather chart like this one, so if you do, you can tell what's going on with it. You can tell here's the isobars, you can see how wide they're out here spaced. This one here is closely spaced, probably heavy winds up around in the Great Lakes area. You know, so you wanna watch what's going on there with the low pressure, remember it's, you know, counterclockwise wind around it. Here's a warm front going up, probably carrying a lot of moisture. Here you got a cold front, overtaking that, and probably gonna be some rain along that cold front with a warm air front that close, and they're hitting each other right there. It's probably gonna be fairly nasty, warm here or high pressure here. So you can look at those and tell what's, you know, have an idea of what's happening. You can get an idea with the wind, you can get an idea of, you know, is it gonna be here, probably fairly decent weather here. There's not, you know, we don't have any kind of fronts or pressure zones right over top of us. It's probably pretty decent. So, that's about it for the weather for tonight. Anybody have any questions on the weather? The only thing you gotta do is you gotta remember this for the next 12 weeks, you know? Yeah, because, you know, it'd be on the, like I say, on the exam, and it's in the NAV general section. We will review a lot of what we went through. We won't do all the weather, but we will do, you know, when we go through review, we'll talk a little bit about weather and some of the basic stuff you need to know and understand. A lot of what we talk about tonight is stuff that you won't necessarily see. I mean, but the stuff that was highlighted, stuff you'll see, high and lows, and warm and cold fronts and pressured front, the fronts and stuff like that. Anybody else have any questions?
Actually, the cyclones, they were high, right?
Cyclones?
Yeah.
Cyclones are not necessarily,
I
they
mean,
go up into the atmosphere again.
But they come down, would that
They
be,
can
do they cause like water funnels and whatnot?
They can,
Okay. So a cyclone and water funnel are
it can,
kind of the same?
well, it
You know,
can.
water spout.
Yeah, water funnel, water
Yeah,
spout.
you're talking about like a water spout. Water
Yeah.
spouts are normally along the front of a cold front.
Wall.
You can have a cold front, and if you have a low pressure that it's coming into, you can have the counter rotation with the low air pressure, with the cold front coming in, and it can cause, that's what causes your squall lines a lot of times. That's what you get with the counter rotation. Squall lines can be nasty. I mean, you know, and they're local. When I say local, they're, 5 to 6 miles usually in diameter, and they track along where the cold front's going. We were down off of Hooper's Island, fishing, and they came across and said there were squall lines approaching. And we were down, like I say, off Hooper's Island, and temperature just dropped. I mean, we're out there in t-shirts, and you go try and find a long sleeve shirt to put on because it gets cold. I mean, the temperature it fell, big time. Luckily, the squall lines didn't come over top of us. They went up almost up off of between the Little Chop Tank and Chop Tank. You could see the squall line. You could see the weather. You could see the front lines passing through, and it was nasty up there. I mean, the boats ran because it got so bad up in that area. That's what causes your tornadoes and your water spouts. Is that, you get that cold air mass coming down with the warm air, and if you have a low pressure in the area with the counter rotation with the wind, that can help build it. That's, cyclones itself don't necessarily, you can get water spouts with a cyclone, but not very often with hurricanes. Hurricanes are mainly you get the wind and the sea surge and the rain.
Just out of curiosity's sake, for that storm we got hung up in on the Grand Bahama, it was like five knots of wind behind us and just pouring down rain. And then all of a sudden it whipped completely around. It was out of the west, and it whipped completely around to northeast, I guess, right at us at 35 I would say we ran into a warm front on that one, didn't we? It was a front with no back, cause it was like 4 hours long.
Probably a low pressure area coming through.
No, I didn't really get the weather memo on that.
Yeah.
Or we wouldn't know, probably.
More than likely. I've been,
It was just weird, cause it never went, I mean, it's like 4 hours long. It
yeah, you just
never
stayed
let
right
up.
there.
Never let up.
Yeah. We did, on a cruise ship we were on, we went out, come down the bay, then out, we were going to the Bahamas, or Bermuda, not Bahamas, but to Bermuda. And, when they came out, before they made the turn to go out to Bermuda, they go down by North Carolina, and then they make the turn. We left on a Sunday, and before we left, because of being, involved with everything going on, I'm watching everything, watching the weather too, so I'm watching the weather. Well, there's a storm coming up, but this is the beginning of May. There's not a hurricane, so they're not forecasting a hurricane because it's in 1st of May. May, you don't have hurricanes until June.
Oh, yeah, good point.
So, storm came up along the coast, they came up, we turned to go to Bermuda, and when they turned to go to Bermuda, Monday morning, we hit 70 plus. And our stateroom was on the 2nd floor, we had waves breaking by our window. It was nasty. Didn't affect them a whole lot. I mean, it affected everybody on the boat. Everybody on the boat was just about sick, but everybody, for the most part, I mean, everywhere you went, they had barf bags stuck everywhere, for you to use, but, we were prepared, we didn't get sick. But the deal was, they made almost as good a time as they normally would. We got there, 12 hours later than what we normally would, and what they should have made. So that's not bad. I thought that was pretty decent for,
We had to come down further for crossing the Gulf Stream, right? Cause that was gonna shift you back up.
Yeah, that's what they do.
That's why
They come
go to
down, they
North
hit it,
Carolina.
and then they take it across, helps push them along.
Yeah, we got stuck in the ocean too that one time and figured out
Yeah.
finally the Gulf Stream.
We had, we've had one student that came through the class, he was a young guy and came through, and what was the name of that boat? What was the, out of Massachusetts?
I don't remember the age group.
I used to have it on the slides, I can't remember. There was a boat came out of Massachusetts, he was supposed to be on it. He was working on a tall ship on the west coast, and he had taken a position on this boat, to take, and they were supposed to go to Massachusetts and meet him in Mass. And they were gonna take the boat from Mass to Florida for repairs, to have work done. They went down, came out. The captain on the boat was a very, very skilled captain. I mean, he'd been running the boat for years, he missed the timeline to be able to get to Massachusetts, so he was gonna fly to Florida. So he flew to Florida. Meantime, they're bringing the boat down from Massachusetts, they come down, the hurricane coming up. They weren't in the hurricane, but they tried to maneuver around, they come in, they got hit off North Carolina and sank the vessel. The captain, 2 crew members died, they recovered everybody else, got everybody else off. But the captain himself, he died in the sinking, but there was 2 other crew members that also died, and then like I said, he was supposed to be on it, and he ended up, luckily, he went to Florida instead of being up to Massachusetts to be on it. There's a lot of storms in that, when you go down along the coast, you gotta be really watching. We went down, took the boat down, and went down around Frying Pan Shoals and go down, we got across Frying Pan out there, across there, and we're going out, and we come back along, winds all of a sudden start coming up out of the southwest and hitting us, and these are not light winds, they were blowing, 20, well, they weren't like 40s or 50s, but they were, 20, 25, and 25 knot winds, is a lot of wind out there on the ocean. And we trying to go to Morehead City, where we're trying to get into, and so we were coming across and trying to get down to Morehead City, and actually, we'd even called the Coast Guard, it was that bad. We called them, and they told us, said, good luck. That was their comment. I mean, you know, cause, you know, there was some of the extra marinas, you know, there was some harbors and stuff you get into, but you couldn't get into them because you couldn't get into the harbor. You know, we draw about 5 feet of water, you know, and there, you know, some of the harbors going in are only had a foot and a half, 2 feet of water to get into them. And so we couldn't, there was no way to get into them. And then they said, yeah, we told them we were going to Morehead, and they said, the best thing we can tell you is just watch the weather and keep, you know, just keep moving. That's what we did. We made it Morehead City. Had dinner and a couple drinks. We had waves breaking over top of the sport fish. It was, you know, 50-foot sport fish, and had waves breaking over top of it. And, you know, not where you want to be. Yeah, it can. You really got to be careful when you're out like that. You know, that's the kind of thing you really got to watch. You got to watch the weather constantly. And
You just gotta watch the weather, period, that's it.
I mean, if you're going out for a day, it's one thing, because you watch the weather, you know what's happening, you see what's going on, and you have a pretty good idea, and you know you're gonna be in before this storm gets anywhere close. But if you're out there off the coast and you're traveling down the shoreline, or you're out there, you know, out in that, they can get bad in a hurry. I mean, you know, you don't wanna be out in that. You know,
Did you ever pay for doing these weather briefings with Chris, was it Chris Parker or whatever? The one guy, he was routing the weather, whatever. I think it's Chris Parker.
Yeah, I know you're, yeah.
You gotta pay him for it, I mean, it's like $50 for a weather plan.
Yeah, he'll give you, he'll tell you what's going on. What you want to do is when you go through and you read those questions, what I would suggest to do on your home study questions is to read the question, go through and read all the questions, then go look for the answers. You know, look at all the questions first, then go look for the answers. If you go and you try to read a question and go look for the answer, you know, you might, yeah, you're getting that one, but you know but you'll get more out of it if you read all the questions and then go look for the answers. You know, if you need, because there may be questions you may be able to answer when you read the question. And there may be questions that may answer. You're reading one question and you get down, you're reading question 3, and you get down to 25, and 25 answers 3. You know, because of the way, you know, when you read 25, you go, oh, okay, that's the reason that's the answer. It's right there. You know. So sometimes, you know, that'll happen. That'll happen on exams too. So make sure you read through and you read every word. And when I say every word, I mean spend the time, you know, reading, because that's where when you take the exam, the biggest problem people have are misreading the questions or misreading the answers. Well, like tonight, you had one question in your homework that had, you know, went back over, there was one question that had the word except. So what they're looking for is a wrong answer. You know, they're looking for one that doesn't match what they're asking for. And that's what you gotta remember. There's also a couple other words in the rules that you need to understand. One of them is may. The other word is shall. You see a question with may, or you see a rule with the word may, what it's telling you is that it is your discretion. It's the captain's discretion. You may do this. This is what you may do. But if you read the word shall or must, that's what you've got to do. You've got to follow it word for word in the rule, unless it puts you into danger, and then you can use rule 2 and get out of it. But you got to remember, may is captain's discretion. Shall is what you have to follow. You have to follow the rule. You'll see those in questions. Also, like I said, see the word accept, especially in the rules questions, you'll see it. And they'll be giving you the questions and you read the question. And I guarantee you that a lot of people that got questions wrong on the exam, they just didn't read that word. Because they look and they see the one answer, they see an answer, oh, that's the right answer, it matches what they're looking for. I'll pick A. They pick A.
Except.
Except, it's not A. They're looking for C. So that's what, you know, just things to remember. Just take your time, read through it. Next week, we'll be going through the rules. When we go through the rules, we're gonna go, it's not really to cover the rules for you forever, you know, it's just to kind of give you an overview to help you study and to help you understand a little bit more about what we're doing. Because tonight you've got the first part of the steering rules and the home study questions. So they're talking about the first part, risk of collision, and how do you define risk of collision, and safe speed, and lookout. And that's part of the questions you'll have or this week's home study. And then you'll get into who has to get the giveaway vessel and the stand-on vessel. That'll be the following week. But then we'll get into lights and shapes and signals. So when you get into those, you need to. The first 6 weeks of the class, every week will be a certain segment of the rules. You'll have certain rules to read about and study, and that's what your home study will be on. Will be that certain segment of rules, and so that's what you want to concentrate on that week. But don't forget the previous week rules that you've studied. We get up to week 6, we'll be through all 38 rules. We'll be through the rules segment. Week 6. Week 7, we'll start. You'll get 50 questions on week 7, 8, 9, and 10. Those 4 weeks will be 200 questions. Will be review questions. Those questions can be from any of the rules. It won't be of one segment. It's like, right now what you're getting is when you get hit with questions on your home study, they're going to pertain to the rules that you've got for the study for that week, for the most part. There'll be a few questions thrown in at the end that might link back to a couple of the questions, or a couple of the rules earlier. But for the most part, it is what the area that you're given for study for that evening, but for that week, home studies. Like this week, I think it's 4 through 9 or something. I don't remember what it is I can't remember what they are, but they were. I know it's the steering and sailing, beginning of steering and sailing rules. And then you'll have like I say, the giveaway and the stand-on vessels. That'll be the following week. When you get those 200 questions, when we start doing those review questions, they're going to be very similar to what you're going to see as exam questions or exam tests. You're going to have 4 weeks of 50 questions that are going to be very similar to what you're going to see on the exam. So that's when you want to, make sure, that's when you want to start making sure you've got the right answers. Right now, if you miss an answer, if you miss a question, or if you miss the rule, or you miss, understanding what you're looking for in the question, it's not a big deal, because right now, okay, I missed it, and I'll go back. Why did I miss it? Go in the book and look back and look at the rule and see, okay, why did I miss that? Why was that? Why is it that way? And study it that way, instead of, oh man, I missed it. Just throw everything away. No, you got to get into it and then study, the area that you're studying. The rules more so than the deck general and deck safety and nav general. Nav general, deck safety, deck general are 70% in their open books, and we're going to go through the light list, the Coast Pilot, the CFRs, the tide and tidal current books. We're going to go through those books and show you how to use those books to answer the questions that you're going to see. And if you use those books, you'll probably pass the test. If you know how to use the books to look up the information. If you don't use the books to look up the information, it's kind of hard to, if they ask you what color light's supposed to be on a certain type buoy, and I don't know, I can go to the light list and go look up the light, find it in the light list, and it tells me right there, it's got to be this type of light on it. And that'd be the answer, so I, bang, I got the answer right. If I don't go look it up, I go, maybe it's a red light, I'll pick red, no, it's white. It's supposed to be a white light on there, but if I pick red, it's wrong, and and I could have looked it up in the light list and gotten the right answer. So, if they ask you what type of a definition with something with doing with tide, I can go look in the tide book and look in that, and give you a definition, what it's supposed to be, and there's different places you can go look. Coast Pilots, Book of Local Knowledge is what it basically is, what they are. What the Coast Pilot is like, if I'm going into an area and I've never been there, and Brandon's been in there, he's been there, time after time after time, and I'd say, well, I'm going to such and such, and he says, well, when you go there, when you go into the entrance, you wanna make sure you stay over to this side, and then look for this, and then, you can turn and you go up in there. Oh, and there's a marina up there right on the right side as you go in. You go out and go around that buoy, but you gotta go around that buoy and come back to the marina. Don't just cut across and go to the marina. He can tell you all that.
Does he really know it?
Well, if he doesn't, I can look it up in the Coast Pilot, and that's what the Coast Pilot will tell me. So if I've never been to an area and I'm going into an area and I wanna know how to get in and out of an area, I can look at it and look in the Coast Pilot. And it's a book of local knowledge, usually, and they'll have pictures a lot of times. Well, I show what the harbor looks like going into the harbor or something, it gives you an idea of what you're supposed to be looking at. The nice thing is you can get a book and carry it with you for each particular area. We're in Coast Pilot 3 is our area that we're in. It goes down to Cape Henry, and then when you go down further, you gotta have Coast Pilot 4, and you go down to Florida, Coast Pilot 5. And so, different areas is different Coast Pilots, so, to make sure you have what you need, or, access to what you need before you go. If nothing else, then we're done for the evening. We're gonna have a couple of minutes early. That's a